Welcome, welcome. This is your video for section 1-3, part B. So we did the first part of this section yesterday. Now you're working on the second part of this section. It's still talking about real numbers in the number line, but today what we're going to do is classify. So here's the goal that I want to have, you should have written down in your binder on the goal sheet. I can classify, graph, and compare real numbers. So it is three things in one. We'll try to get through it as fast as we can. I do have a few key vocabulary right there. All the different types of numbers that we're going to classify. Real numbers, rational numbers, natural numbers, whole numbers, integers, and irrational numbers. Okay, so you'll get used to what is what and how we can classify numbers with those. So, first thing I want to introduce to you is just the types of numbers and their definitions. So, the first one, a rational number. So a rational number is any number that you can write in the form a over b, where a and b are integers and b is not 0. So I guess to put that into perspective, a rational number is pretty much any number that would be, well, I'll explain some examples that I'll go into there, but you can, as long as it's something that you can, let's do 6 divided by 4. Those are both integers, and neither of them are, or the bottom one is not 0. Okay. What about 3 over 3? That's equal to 1, and that works. Okay. We could even do 3 over 4. We could do 3 over 1. There's so many different possibilities for rational numbers, and I think once we do a chart in just a little bit, you'll get a better idea of it. The next one I want you to just introduce, though, is natural numbers. Natural numbers are also called counting numbers because when you first learn to count, you started going 1, 2, 3, 4, so on. So these are called counting numbers because it's numbers that are all positive and they're all whole numbers. Okay, and that's shown on a number line there. Okay, now whole numbers, now these are all rational numbers, first of all. Whole numbers are counting numbers plus 0. So whole numbers are the same thing as counting numbers, but 0 is also included in whole numbers. So if you look at the number 3, the number 3 could be considered a rational number, a natural number, and a whole number right now. Okay? Next. So this is the thing that was added to it, sorry. This is a 0. Integers are the same thing as natural numbers, same thing as whole numbers, but we also add, so I'm going to right here add 0 to the list. Now we're going to add negatives. So integers are any whole numbers, any whole numbers and negative whole numbers. So as long as there's no decimals or fractions between two whole numbers, these are all called integers. You think of the basic number line. These are all examples there. Now an irrational number. So we talked about rational numbers. Now we're going to say, what is an irrational number? Well, an irrational number is something that cannot be represented by a quotient of two integers. In decimal form, they do not terminate or repeat, meaning the decimal never stops. So it's a decimal that goes on forever, but it also isn't a repeating decimal. So a couple of examples here. 0.10100100001. So it's not the same repeating thing, and it goes on forever. Pi is the classic example of an irrational number because it goes on forever, as you know, 3.141599265. No one knows when it ends. Note here that some square roots are rational numbers and some are irrational. If it's not a perfect square, its square root is irrational typically. So rational numbers, perfect squares. We talked about perfect squares last time. Irrational ones would be like the square root of 3. And if you put it into a calculator, the square root of 3 is all that really long decimal that never ends. Square root of 10 would work. Square root of 2 would work. None of those are perfect squares, so they're going to be irrational numbers. And lastly, all rational, so all of these numbers and irrational numbers, since these are all natural numbers, whole numbers, and integers are all rational numbers, if you do irrational and rational numbers together, those all make up the set of real numbers. So when we're talking about real numbers, this is all we're talking about. Because believe it or not, there are imaginary numbers. Chances are you won't learn about imaginary numbers unless you go into college math. But real numbers is basically everything you're going to work with until then. Okay? So I'd like to take all these definitions, all these terms, and put them in a little bit different way. So I'm going to make a little a chart here. And you might benefit from this as well if you make this chart yourself. So let's say these are all the real numbers. Okay, real numbers are all inside of here. Okay, so real numbers, we have two other boxes that are separate. I'm going to make two other boxes in here. Inside of real numbers, we have, I'm going to put one smaller, one bigger. Inside of here, we have, I'll type this in here, irrational. And if you remember from just up top, irrational numbers include numbers like, they're numbers that they go on forever. So like, example of an irrational number would be the pi, so 3.14, and so on. It goes on forever. It's not just 3.14. The square root of 2 would be an example. The square root of 10 would be an example. Those are some examples of irrational numbers. Now in here, we're going to have the box of rational numbers. See, rational numbers, there's a lot of different things that can go into rational numbers. Some of the basic rational numbers that we're talking about, anything that would work as fractions. So in this box, I'm just going to put, oh, actually, you know what? There's other things that go into rational numbers as well. And we have integers, whole numbers, and natural numbers. So I'm going to make some more boxes here. Inside of rational numbers, we have, whoops. Okay, we'll try this. Another part of we have integers. Whole numbers. And then lastly, natural numbers. And I'm just going to write natural here. So let's start from the inside out. I think this will be easiest. Natural numbers include counting numbers. So we have 1, 2, 3, etc. Whole numbers would be 0, 1, 2, 3, etc. So we have all of the natural numbers are inside of whole numbers, but 0 is also part of it. So these are all also part of integers, but integers also have negatives. So we have -2, not sure what happened there, -1, 0, 1, 2, and so on. So integers include whole numbers, natural numbers, and negatives are added to it. Rational numbers are all of those. So we have negatives, we have 0, we have positives, we also have decimals like 6.4, and fractions that don't repeat or go on forever like 3/2. Those are all rational numbers. And all of that makes up this whole box of real numbers. Okay, I know that was a lot, but I wanted to show it as a diagram as well. And so let's do a couple examples here. So let's start classifying some numbers. So this first one said, to which subsets, these are all subsets, of real numbers does each number belong? So number 15, what do you think? Number 15 fits in what? Is it an irrational number? I don't think so. It is definitely a real number, but 15 could be rational, could be an integer, could be a whole number, and it could be a natural number. Okay, so that would work in all of these: natural, whole numbers, integers, and rational. Okay, negative 1.4583. It doesn't look like it goes on forever, so we're going to say that it's not a natural number, it's not a whole number, not an integer. It is a rational number though. Okay, it's a terminating decimal. That means it stops. It doesn't go on forever. Square root of 57 though, if you're not sure, you can use a calculator. 57, square root of that, looks like this decimal goes on forever. So that is going to be an irrational number. It's definitely not rational. Okay. So why don't you try some of these on your own? You can, hopefully you wrote this box down or the definitions down. That's what I expect from you. I'd like you to use that and to try to answer these questions here. A, B, C, and D. What do they belong to? You can pause it and go. Okay. So square root of 9, that is equal to 3. So that's just a whole number. It's a natural number. It's an integer, and it's a rational number. So it's all of those. Rational. Oh, oops, I skipped integers. There's an integer, and it's also a natural number. Fits in all those categories. We're really just saying what do these numbers fit into? What categories do these fit into? Okay, if we're putting this into a decimal, it'd be 0.3 for B, or 3/10. Now, is a decimal a natural number? Nope, those are just counting numbers. Same with whole, same with integers. But it's a decimal, but it terminates, so it would be rational and not irrational. So it fits into the rational number category. And we know these are all real numbers, so you don't have to say that. Negative 0.45. It's another decimal, but it doesn't go on forever. So that one is also a rational number. Now, the square root of 12. We said every square root that's not a perfect square would end up being a decimal that goes on forever. So that means that this is an irrational number. Okay, the point of this is that you can classify numbers. You can tell me what categories they would fit into in the real number system. Are they just irrational, or do they fit in one or more of these, or multiple of those? Okay, that is classifying numbers. Now we're going to do a little bit on ordering numbers, putting them in the correct order. And that's where we get to this word called inequality. We're going to spend a whole chapter on inequalities, but I just want to review basics of inequality. It's a mathematical sentence that compares the values of two expressions or numbers using an inequality symbol. And these inequality symbols you've learned before. So if it opens to the right, that's representing less than. So that means something on the left is less than something on the right. If it opens to the left here, that means it's greater than, so something on the left is greater than something on the right. And if you're never sure, it always opens up to the bigger thing. So keep that in mind. Same thing works for less than or equal to, greater than or equal to. So, question for you is, how do you compare numbers that are tough to compare? So if I said like 3, oops, 0.365 and 1/3. Which one is bigger? Which one is smaller? It's tough because they're both going to be between 0 and 1. And we don't know off the top of our head maybe because one is a decimal and one is a fraction. Well, you can always put them into decimals. So either way, I would say make them, I would put them into decimals. Put them into decimals, or, yeah, we're going to say this, make them decimals. So we got 1 as a decimal already. 1/3 is actually going to be 0.33 repeating. So we have 2 decimals now. And the second thing I would like you to do for comparing numbers is to put them on a number line. Number lines are your friend. I actually have a number line in the classroom. You can use that. You can use them on your paper. Number lines help you to compare numbers. They also help you to add or subtract if you need them for that. But we have an example here, example 1, that says, what is an inequality that compares the number? So if you look over here, I think for this one up here, the 0.365 is bigger than 0.33. So we'd say 0.365 is greater than 1/3. That's our inequality. What's an inequality that compares square root of 17 and 4 and 1/3? Well, why don't we make them both into decimals? So let's say make them into decimals. Square root of 17, let's pull out our calculator. That's 4.12, we'll see. And 4 and 1/3 is actually going to be 4.33 on average, approximating. So then put it on a number line. Let's see. Remember, the bigger numbers go to the right. So this is 0, 1, 2, 3, 4. Oh, we need higher. 5. 4.12 is going to be, let's say this is 4.12 is really close to 4. 4.33. So the 4.12 is smaller than the 4.33. So we're going to make it open up to the 4.33. Or really, we'd say the square root of 17 is less than 4 and 1/3. It's really easy once you put them, oh, why does that keep happening? It's really easy once you put them into decimals. Okay, multiple choice. I'd like you to answer this one on your own. I would like you to order those from least to greatest. I have 4 options. Pause it, take some time to figure this out, and then tell me which one is, or what is the order, what's the correct order from least to greatest. Okay, so let's take a look. Again, put them all into decimals. Square root of 4 is 2. This is 2.0. This is 0.4. This is negative 2/3. So it's negative. I'm going to take these down here and do this. Square root of 4 is 2. 0.4 is 0.4. So that's going to be smaller already. Negative 2/3 is going to be negative 0.67 approximately. Square root of 2, well, let's put it in the calculator. I don't know that one. 1.4. And then negative 1.5 is negative 1.5. So let's look at a number line here. If I were to make us a number line, I don't have to make it very big. Negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Okay, so looking at this, we can put we can move these things around to where they belong. So 2.0, well, maybe I'll just draw arrows for right now. 2.0 goes right to there. 0.4 goes right about there. Negative 0.67 would be right about there. 1.4 is right about there. And negative 1.5 is all the way over here. So from least to greatest, we got this one first. So it would be our first one. Second one is right here. Third one is right here, so that goes right there. This is our fourth. This is our fifth. So let's look up here which one works. So negative 1.5 is our first one. That means it's got to either be C or D, or C or B. Next one should be negative 2/3. Oh, here we go. Already got it. C is the correct answer, because none of the other ones fit, even the first two. Okay, so that's how you order numbers. Put them all into decimals and it makes it really easy using that number line. All right, so just to jump back, our goal is to classify, graph, and compare real numbers. So we classified them by putting them into real numbers. We did rational numbers, natural numbers, whole numbers, integers, and irrational numbers. We graphed them on a number line, and we compared them by making them decimals and putting them on a number line. We also use some of those inequality symbols. Okay, so look for some more practice in class. And again, thank you for watching. Keep watching the videos, keep learning, and keep practicing. You'll become better and better every time. All right, we'll see you next time.